Bismillahirrahmanirrahim. Today we are starting section 2.3 of additional mathematics, and in this section we will see the plot of the graph of y is equal to modulus fx, where fx is a quadratic or a parabolic function, and we will sketch the graphs of y is equal to ax square plus bx plus c. Reflect in the x-axis the part of the curve that is below the x-axis. This modulus shows that y will never go below 0, so it will always be positive, like this. This parabolic function was basically representing like this, but this part which is negative has been reversed due to this modulus. So in this exercise 2.3 we will solve all these problems. Let's start exercise 1a. So for this a we have to sketch it. So y is equal to 0, then x is equal to 0, y is equal to 3. So the y-intercept is 3, and when y is equal to 0, then x becomes 3 and 1. So y-intercepts are 1 and 3. The x-coordinate of the minimum point is 1 plus 3 divided by 2, by the average of these two values, or midpoint of these two. So this is 2. The y-coordinate of the minimum point is this, minus 1. The minimum point is, so we have plotted it like this: 1, 2, minus 1, and y-coordinates are also touching it at x is equal to 0, y is equal to 3. So it should like this, be like this. So we have to plot the modulus. So we will see that the graph is going below this value, so we will draw it like this. So this is the required graph of this. This one is without modulus, but this one is with modulus. So we can understand that what is happening here. So this part A is draw it like this. So 2 minus 1 is 2 plus 1. Similarly for problem number 2, see this, so it will reverse back like this. We solve it with a similar way as we done it earlier. So this is the requirement. For this part we have this, and we have to reverse this shape and appear like this. This shape has to be, so because the space was not available, so we have drawn it this shape into this. So this is the graph. So problem number 2, we have to express this function into this shape. So actually we write down like this, and by comparing coefficient, like the previous case, we have obtained these values and raised it, and by looking at this function, we can say that -2 and 5 are the maximum value because this coefficient is negative. We have obtained these values and the plot is like this. And here, if this is modulus, it will go the side. This. So for problem number 3, we have to express this in this form. So this form has to be expressed in this form. So eventually we have write down this form and we have plotted it and we have obtained like this. So this has to be upside like this. For part C, coordinates of the stationary point on the curve. So this is the stationary point, so it becomes this. So part C, for graph at k is equal to 16, there are 3 solutions, but in the range 0 to 16 there are 4 solutions. This value we have 3 solutions, above this we have 2 solutions, and at this points we have 1, 2, 3, 4 solutions. So we can understand the number of solutions depends on there are 4 solutions. Below the k 16 there are 4 solutions, and at k is equal to 16 there are 3 solutions, and above that we have only 2 solutions. For question number 5, we have these 2 values and we have plotted it like this. Now we have to find from the graph 4 is less than k or 4 is greater than k. Only 2 solutions exist. This 6a, we have x is equal to 0, y intercept is 24, at y is equal to 0, x intercepts are 3 and 8. So x coordinate minimum point is this, and y coordinate minimum point is by placing these values 3 and 8. We have obtained these values. From graph k is equal to 6.25, there are 3 solutions. So between this and this 4 solutions exist, or between this 2 solutions exist. So problem number 7, we have this kind of results. X is imaginary, the solutions are 2 solutions positive and 2 imaginary. These solutions, we have these solutions. For C, we have these solutions. For D, we have a solution like this. For H, we have these solutions. I, now we will solve from this. We can see that this is modulus, this becomes positive or negative. This modulus will give a negative value as well. So we never know that whether this is 4 or -4. So we have obtained some solutions. So 2 positive real solution and 2 imaginary solutions. So we will solve we will discuss section 2.4 in the